Good afternoon, everybody. My name is Mitchell Norvalls, and today I will be covering my DSARI project. For the background of my project, my apartment is part of 44 North Apartment Complex, which is roughly a 10-minute walk away from the main campus. Inside the 44 North Apartment Complex, I live in a two-bedroom, two-bath apartment that I share with two other people. And despite sharing this with two other people, I do have one of the bedrooms to myself, which is where I measured all the devices. It is approximately 750 square feet. I couldn't get an exact number as even the 44 North website did not have the numbers for me, so I kind of just had to measure it. The photo act the in the slide to the right there is my apartment layout. You can see there's the central kitchen area, and then there's the two bedrooms, which I have one of them. Using the data from the Minnesota Department of Commerce and the U.S. Energy Administration, both of which I looked up, I was able to calculate using the average square footage and the average kilowatt hour usage of the houses in the US to find the average kilowatt hour per foot squared per month to be around 0.67. This data indicates that an apartment the size of mine should consume roughly 500 kilowatt hours per month. And then using the average of 0.166 per kilowatt hour from the Bureau of Investigation or from the Bureau of Labor Statistics, this came out to roughly $83 a month for an apartment my size. Since 44 North only gives me the cost of my electricity, I can roughly calculate that my $50 a month electricity bill means I consume around 301 kilowatt hours a month, which is slightly lower than the average. Energy context. I do not know my exact energy use percentages, as I said in the background before, but I can assume it is mostly from my online habits, such as gaming or studying, and AC, as I like my apartments colder than average, which is why it's typically running. The devices that I will be measuring in this audit are my gaming laptop, which has an average energy usage of around 12.2 kilowatt per month, my wax melter, which has an average of 3.6, box fan with an average of 54.3, lava lamp with an average of 5.25, phone charger with an average of 1.8, alarm clock with an average of 0.75, Amazon Alexa with an average of 2, and a standard light bulb with an average of 4.2. For the lava lamp specifically, I could not find a source with an energy usage average, so I instead found a source that told how many hours were used on average, and then using my 25-watt light bulb in there, I calculated. And then the image to the right is of a game from my Steam account, which is an online game platform, and it just demonstrates how much I would be playing games, and that's why I would think it would be gaming that would be contributing to the energy. Photos of device measured. There are four photos here. The first one is of my laptop. Second one is the alarm clock. Third one is my phone charger. And the fourth is my box fan. This is the second slide here. The first one here is the lava lamp. The second one is the Amazon Alexa. And the third is my wax charger. For the fourth, I do not have a photo because I could not measure it as I couldn't figure out how to either both I couldn't plug it into the thing, and I also was unable to reach it or unscrew its cover. Therefore, I just used the stand-in that was on the DSARI rubric, which was 20 watts. Here is my daily log for the energy audit. As you can see, I just wrote down how many hours I used, and you can kind of see based on these numbers that I had a specific strategy because these aren't random numbers. They're either a just like a whole number or they have a decimal of 0.5. This is because I chose to use a bit of a unique method to measure it instead of timing how long, because I felt like I would forget that the moment I walked away or like I would mistime it and it would make my data inaccurate. I instead would set like a set timer, like for like my wax melter. If I the moment I turned it on, I would set a timer for 3.5 hours. And then when that timer went off, I would go over and I would shut it off for the week or for the day. Uh, I did this with pretty much everything apart from the stuff that I either left on 24/7, such as the box fan, alarm clock, and the Alexa. And the gaming laptop was a bit of an exception because unfortunately, because I use that for schoolwork and gaming, I went over my timers several times. So I typically would just have to make a new one, or I would just at that point, I would use the regular method of just trying to time how long I was, with the difference being that because the rest of my data was formulated that way, I didn't want it to be different. So I just kind of like if I, for let's say, for instance, Sunday, if I was doing studying for about like 6.5 hours and my timer was for 6 hours, I would go for 6.5. And then just to make it round out and be even, I would keep it on for an additional 30 minutes or like do an extra 30 minutes of studying to make the data more clean. Here is my quantified data. As you can see, every room that I used was the bedroom because all of these were my personal devices. I was going to use, and this is in my later slides as well, I was going to use the ones in the kitchen, such as the bigger appliances like the oven or fridge, but I could not access the plugs. There are the four under appliances. There are the eight of them with the watts on and watts off. All of them, apart from, or all of the constant ones, they were relatively, they all had about like on the watts on, you can see there, and then the watts off, they had zero, apart from the alarm clock, in which it still drew 0.8 watts, even if it was off, because it was battery operated. And so it's still drawing that power, even if it's unplugged. There's the average days and the auto calculations. The hours plugged in for the variable devices was my gaming laptop, and I plugged it in for 24 hours and then measured the kilowatt total, which it calculated below. And then the cycle measurements was for my phone charger because I would essentially plug that in, I believe, once per day for about 4 hours, which was a full charge for my phone. And then that would just be it for the day. And I would try and not plug it into again to make sure that the data stayed constant. Here are the calculations for the slide previous. So there's two categories here, technically three. I just lumped phantom power into constant as well. The formula I used for constant was energy equals power times time, such as with the box fan, it was 72.8 watts. That was the power. And I used it for 24/7. So it was 24 hours for 7 days. So that multiplied, and then I divided it by 1,000 to get the kilowatt hours. So the box fan, its final calculation was 12.23 kilowatt hours. The one that had the most phantom power was definitely the like alarm clock, Amazon Alexa, because even when they were technically off, they would still draw power. Like Amazon Alexa, it stays in an idle form and just kind of stays on all the time, even if it's like not doing anything. And the alarm clock, even when unplugged, it would still draw power from the battery within it. The variable was only the gaming laptop, and there wasn't really a set formula. I just added up the kilowatt hours that I calculated for each day, which was the kilowatt hour, the kilowatt hours that it consumed during its like a session of use, and then I divided it by the time that was during that session. So like if it was, I'm just throwing out numbers. If it was like a 1 kilowatt hour session, power used during a session, and then I would divide it by like 7 hours, and that would give me a certain amount. I then added those up for the 7 days, which gave me a total of 1.93 kilowatt hours for the laptop. What I learned. From this energy audit, I was able to find that my box fan far outclassed even my laptop in energy usage, as it was running every hour of the day with the same wattage as my computer was during heavy usage. This was slightly surprising, as I figured that a running box fan 24/7 would not be very energy efficient, but I was surprised by how much the fan dwarfed the other devices in energy usage, especially my computer, which I thought would be the main source of energy consumption. The other devices were not as surprising, with the other six devices not even reaching 1 kilowatt hour for the entire week of energy usage. Each one of them was below 1 kilowatt hour for their energy usage for the entire week. Comparing the energy consumption, found my audit to 301 kilowatt hour a month. I calculated in the second slide. It is obvious a majority of the energy I use is not from my personal devices. As I have stated previously, this is most likely due to the usage of my AC or the much larger devices in my apartment, such as my fridge or oven, which as previously stated, I would have measured, but I don't think I could have. Comparing my results from the audit to the averages I found previously, I'm actually below average in my energy usage. Each device apart from the light bulb was either nearly identical or well below the averages I had found. And this did seem unusual to me, as I thought I was above average for computer usage, because I use my computer a lot for both studying and gaming. So I thought I would be above average, but my energy usage was below. For the other devices, I kind of expected the results, as I barely use them most days with like my wax melter. I typically don't really use it. I only would turn it on to like get the data for the audit. Like I would time 3.5 hours, like I said previously, and then turn it off. Leaves them in like a low energy idle state, with most consuming zero well off or very little. The light bulb being the only outlier makes sense, as I am a night owl and use it far more than other people. So that's why my power usage was way higher for the light bulb. Here is a diagram that's actually illustrating my energy use, and it's going to help me explain how I can reduce my energy use. As you can see, the box fan is completely dominating my energy use, with well over 50% of my energy being devoted for that. Uh, I keep it on 24/7, and it has a relatively large power draw, which makes it consume more energy than all of the other devices measured combined by far. Well, I do not like to have it off, and I probably will keep it on most times when at my apartment. I'm only at my apartment around half the time during the day, with most of the time I'm either out with friends or at school. So an easy way that I believe I can reduce my energy by a significant amount is just turning off my fan whenever I leave my apartment, and then, of course, turning it back on when I return. I assume this will drop the energy consumption of my fan by half, because if it's off half the time in comparison to what it is now, it should consume half the energy. And then, in conclusion, my energy audit was very informative. It revealed to me the massive disparity between the majority of my personal devices and my box fan energy usage. I was only somewhat surprised by the data I found, as I expected the results to some degree. I just did not expect the fan to consume that much energy. And then from these results, I have made a clear plan to reduce my energy usage by simply turning off my fan when I leave my apartment. This should cut the energy used by my fan in half. This would save around 26.2 kilowatt hours per month, or 35% of my total power usage if out of the 8 devices. That one change would drastically decrease my energy usage, as even the combined energy usage of every other device, which is 21.88 kilowatt hours per month, is still less than the saved energy of 26.2 kilowatt hours. I will also try and turn off my devices before going to bed. It's a bad habit, such as I would leave my lava lamp, I would turn it on before going to bed. I would scroll on my phone, and then I would fall asleep, and I would leave it on overnight, and then I would wake up and turn it off. And then, of course, here are the references. There are 11 references, and that should be about it for my presentation. Thank you for watching.